Hello and welcome to everyone. Now, today I am going to start the book reading session on science subject chapter 1 for RRB, JE, Ntpc, Group D as per attached syllabus Ncert based. The first chapter is Matter in Our Surroundings. As we look at our surroundings, we see a large variety of things with different shapes, sizes, and textures. Everything in this universe is made up of material which scientists have named matter. The air we breathe, the food we eat, stones, clouds, stars, plants, and animals, even a small drop of water or a particle of sand, everything is matter. We can also see as we look around that all the things mentioned above occupy space and have mass. In other words, they have both mass and volume. Since early times, human beings have been trying to understand their surroundings. Early Indian philosophers classified matter in the form of five basic elements: the Panch Tattva: air, earth, fire, sky, and water. According to them, everything living or non living was made up of these five basic elements. Ancient Greek philosophers had arrived at a similar classification of matter. Modern day scientists have evolved two types of classifications of matter based on their physical properties and chemical nature. In this chapter, we shall learn about the matter based on its physical properties. Chemical aspects of matter will be taken up in the subsequent chapters. Physical nature of matter. Matter is made up of particles. For a long time, two schools of thought prevailed regarding the nature of matter. One school believed matter to be continuous, like a block of wood, whereas the other thought that matter was made up of particles like sand. Let us perform an activity to decide about the nature of matter. Is it continuous or particulate? Activity number 1.1. Take a 100 ml beaker, fill half the beaker with water and mark the level of water. Dissolve some salt, sugar with the help of glass rod. Observe any change in water level. What do you think has happened to the salt? Where does it disappear? Does the level of water change? In order to answer these questions, we need to use the idea that matter is made up of particles. What was there in the spoon, salt or sugar, has now spread throughout the water. This is illustrated in figure 1.1. Here, the particles of water magnified millions of times. Water, salt is added. Now, stir it. Then, what you have find when we dissolve salt in water, the particles of salt get into the spaces between the particles of water. How small are these particles of matter? Take a 2 to 3 crystals of potassium permanganate and dissolve them in 100 ml of water. One point should be noted: the SI unit of mass is kilogram, kg. The unit, the SI unit of volume is cubic meter, meter cube. The common unit of measuring volume is liter, such that 1 liter is equal to 1 decameter cube, 1 liter is equal to 1000 ml, 1 ml is equal to 1 centimeter cube. Take out approximately 10 ml of this solution and put it into 90 ml of clear water. Take out 10 ml of this solution and put it into another 90 ml of clear water. Keep diluting the solution like this 5 to 8 times. Is the water still colored? Here the 100 ml, you can see here 10 ml, then 10 ml, then 10 ml. Estimating how small are the particles of matter, with every dilution, though the color becomes light, it is still visible. This experiment shows that just a few crystals of potassium permanganate can color a large volume of water, about 1000 liters. So we conclude that there must be millions of tiny particles in just one crystal of potassium permanganate, which keep on dividing themselves into small and smaller particles. The same activity can be done using 2 ml of Dettol instead of potassium permanganate. The smell can be detected even on the repeated dilution. The particles of matter are very small, they are small beyond our imagination. Characteristics of particles of matter. Particles of matter have space between them. In activity 1.1 and 1.2, we saw that particles of sugar, salt, Dettol, or potassium permanganate got evenly distributed in water. Similarly, when we make tea, coffee, or lemonade, nimbu pani, particles of one type of matter get into the spaces between the particles of the other. This shows that there is enough space between particles of matter. Particles of matter are continuously moving. Activity 1.3. Put an unlit increase stick in a corner of your class. How close do you have to hear near it so as to get its smell? Now light the incense stick. What happens? Do you get the smell sitting at a distance? Record your observation. Take two glasses beakers filled with water. Put a drop of blue or red ink slowly and carefully along the sides of the first beaker and honey in the same way in the second beaker. Leave them undistributed in your house or in corner of the class. Record your observations. What do you observe immediately after adding the ink drop? What do you observe immediately after adding a drop of honey? How many hours or days does it take for the color of ink to spread evenly throughout the water? Activity 1.5. Drop a crystal of copper sulfate or potassium permanganate into a glass of hot water and another containing cold water. Do not stir the solution. Allow the crystals to settle at the bottom. What do you observe just above the solid crystal in the glass? What happens as time passes? What does this suggest about the particles of solid and liquid? Does the rate of mixing change with temperature? Why and how? From the above three activities, 1.3, 1.4, and 1.5, we can conclude the following. Particles of matter are continuously moving, that is, they possess what we call the kinetic energy. As the temperature rises, particles move faster, so we can say that with increase in temperature, the kinetic energy of the particles also increases. In the above three activities, we observe that the particles of matter intermix on their own with each other. They do so by getting into the spaces between the particles. This intermixing of particles of two different types of matter on their own is called diffusion. We also observe that on heating, diffusion becomes faster. Why does this happen? Particles of matter attract each other. Place this activity game in the field, make four groups and form human chain as suggested. The first group should hold each other from the back and lock arms like Edu Miss Me dances. To the second group should hold hands to form a human chain. The third group should form a chain by touching each other with only their fingertips. Now the fourth group of students should run around and try to break the three human chains one by one into as many small groups as possible. Which group was the easiest to break? Why? If we consider each student as a particle of matter, then in which group the particles held each other with the maximum force? Activity 1.7. Take an iron nail, a piece of chalk, and a rubber band. Try breaking them by hammering, cutting, or stretching. In which of the above three substances do you think the particles are held together with the greater force? Activity 1.8. Take some water in a container. Try cutting the surface of water with your fingers. Were you able to cut the surface of water? What could be the reason behind the surface of water remaining together? The above three activity 1.6, 1.7 and 1.8 suggest that particles of matter have force acting between them. This force keeps the particles together. The strength of this force of attraction varies from one kind of matter to another. Question is number 1. Which of the following are the matter? Chair, air, love, smell, hate, almost, thoughts, cold, lemon, water, smell of perfume. Give reason for the following observation. The smell of hot sizzling food reaches you several meters away, but to get the smell from cold food, you have to go close. A diver is able to cut through water in a swimming pool. Which property of matter does this observation show? What are the characteristics of the particles of matter? States of matter, also of different types of matter around you. What are its different states? We can see that matter around us exists in three different states: solid, liquid, and gas. These states of matter arise due to the variation in the characteristics of the particles of matter. Now let us study about the properties of these three states of matter in detail. The solid state. Collect the following articles: a pen, a book, a needle, and a piece of wooden stick. Sketch the shape of the above articles in your notebook by moving a pencil around them. Do all these have a definite shape, distinct boundaries, and a fixed volume? What happens if they are hammered, pulled, or dropped? As these capable of diffusing into each other, try to compressing them by applying force. Are you able to compress them? All the above are examples of solids. We can observe that all these have a definite shape, distinct boundaries, and fixed volumes. That is, have a negligible compressibility. Solids have a tendency to maintain their shape when subjected to outside force. Solids may break under force, but it is difficult to change their shape, so they are rigid. Consider the following. What about the rubber band? Can it change its shape on stretching? Is it a solid? What about sugar and salt when kept in different jars? These take the shape of the jar. Are they solid? What about the sponge? It is a solid, yet we are able to compress it. Why? All the above are solids, as a rubber band changes shape under force and regains the same shape when the force is removed. If excessive force is applied, it breaks. The shape of each individual sugar or the salt crystal remains fixed whether we take it in our hand, put it in plate or in a jar. A sponge has minute holes in which air is trapped when we press it. The air is expelled out and we are able to compress it. The liquid state. Collect the flowing water, cooking oil, milk, juice, a cold drink. Containers of different shapes. Put a 50 ml mark on these containers using a measuring cylinder from the laboratory. What will happen if these liquids are spilled on the floor? Measure 50 ml of any one liquid and transfer it into different containers one by one. Does the volume remain the same? Does the shape of the liquid remain the same? When you pour the liquid from one container into another, does it flow easily? We observe that liquids have no fixed shape but have a fixed volume. They take up the shape of the container in which they are kept. Liquids flow and change shape, so they are not rigid but can be called fluid. Refer to activities 1.4 and 1.5 where we saw that solids and liquids can diffuse into liquids. The gases from the atmosphere diffuse and dissolve in water. These gases, especially oxygen and carbon dioxide, are essential for the survival of aquatic animals and plants. All living creatures need to breathe for the survival. The aquatic animals can breathe underwater due to the presence of dissolved oxygen in water. Thus, we may conclude that the solid, liquid, and gases can diffuse into liquid. The rate of diffusion of liquid is higher than the solid. This is due to the fact that in the liquid state particles move freely and have a greater space between each other as compared to particles in the solid state. The gaseous state. Have you ever observed a balloon seller filling a large number of balloons from a single cylinder of gas? Inquire from him how many balloons is he able to fill from any cylinder. Ask him which gas does he have in the cylinder. Take 300 ml syringes and close their nozzles by rubber cork as shown. Remove the piston from all the syringes, leaving one syringe untouched. Fill water in the second piece of chalk in the third. Insert the piston back into the syringes. You may apply some Vaseline on the piston before inserting them into the syringes for their smooth movement. Now try to compress the content by pushing the piston in each syringes. What do you observe? In which case was the piston easily pushed in? What do you infer from your observation? We have observed that the gases are highly compressible as compared to solids and liquids. The liquefied petroleum gas (LPG) cylinder that we get in our home for cooking or the oxygen supplied to hospital in cylinder is compressed gas. Compressed natural gas (CNG) is used as fuel these days in vehicle. Due to its high compressibility, large volume of a gas can be compressed into a small cylinder and transported easily. We come to know of what is being cooked in the kitchen without even entering there by the smell that reaches our nostril. How does this smell reach us? The particles of the aroma of food mixed with the particles of air spread from the kitchen reach us, and even farther away the smell of hot cooked food reach us in the seconds. Compare this with the rate of diffusion of solids and liquids due to the high speed of particles and large space between them. Gases show the property of diffusing very fast into other gases. In the gaseous state, the particles move about randomly at high speed. Due to this random movement, the particles hit each other and also the wall of the container. The pressure exerted by the gas is because of this force exerted by gas particles per unit area on the walls of the container. The mass per kg unit volume of a substance is called density. Arrange the following in order of increasing density: air, exhaust from chimney, honey, water, chalk, cotton, and iron. Tabulate the differences in the characteristics of states of matter. Comment upon the following: rigidity, compressibility, fluidity, filling a gas container, shape, kinetic energy, and density. Give reason. A gas fills completely the vessel in which it is kept. A gas exerts pressure on the walls of the container. A wooden table should be called a solid. We can easily move our hand in air, but to do so the same through a solid block of wood, we need a carrot expert. Liquids generally have lower density as compared to solid, but you must have observed that ice floats on water. Find out why. Can matter change its state? We also know from our observation that water can exist in three states of matter: solid as ice, liquid as familiar water, and gas as water vapor. What happens inside the matter during this change of state? What happens to the particles of matter during the change of states? How does this change of state take place? We need answers to these questions, isn't it? Effect of change of temperature. Activity. Take about 150 gram of ice in a beaker and suspend a laboratory thermometer so that its bulb is in contact with the ice as in figure 1.6. Start heating the beaker on a low flame. Note the temperature when the ice starts melting. Note the temperature when all the ice has converted into water. Record your observations for this conversion of solid to liquid state. Now put a small rod in the beaker and heat while stirring till the water starts boiling. Keep a careful eye on the thermometer reading till most of the water has vaporized. Record your observation for the conversion of water in the liquid state to the gaseous state. On increasing the temperature of solids, the kinetic energy of the particles increases. Due to the increase in kinetic energy, the particles start vibrating with greater speed. The energy supplied by the heat overcomes the force of attraction between the particles. The particles leave their fixed position and start moving more freely. A stage is reached when the solid melts and is converted into a liquid. The minimum temperature at which a solid melts to become a liquid at the atmospheric pressure is called its melting point. The melting point of a solid is an indication of the strength of the force of attraction between its particles. The melting point of ice is 273.15 Kelvin. The process of melting, that is, change of solid state into liquid state, is also known as fusion. When a solid melts, its temperature remains the same. So, where does the heat energy go? You must have observed during the experiment of melting that the temperature of the system does not change after the melting point is reached. Till all the ice melts, this happens even though we continue to heat the beaker. That is, we continue to supply heat. This is heat gets used up in changing the state by overcoming the forces of attraction between the particles. As this heat energy is absorbed by ice without showing any rise in the temperature, it is considered that it gets hidden into the contents of the beaker and is known as the latent heat. The word latent means hidden. The amount of heat energy that is required to change 1 kg of a solid into a liquid at atmospheric pressure at its melting point is known as the latent heat of fusion. So particles in water at 0 degree centigrade 273 Kelvin have more energy as compared to particles in ice at the same temperature. When we supply heat energy to water, Particles start moving even faster at a certain temperature. A point is reached when the particles have enough energy to break free from forces of attraction of each other. At this temperature, the liquid starts changing into gas. The temperature at which a liquid starts boiling at the atmospheric pressure is known as its boiling point. Boiling is a bulk phenomena. Particles from the bulk of the liquid gain enough energy to change into the vapor state. For water, this temperature is 373 Kelvin. 100 degrees centigrade is equal to 373 Kelvin. Can you define the latent heat of vaporization? Do it in the same way as we have defined the latent heat of fusion. Particles in steam, that is water vapor at 373 Kelvin have more energy than water at the same temperature. This is because particles in steam have absorbed extra energy in the form of latent heat of vaporization. Solid state heat, liquid state heated into gaseous state. So we infer that the state of matter can be changed into another state by changing the temperature. We can learn that the substance around us change state from solid to liquid and from liquid to gas on application of heat. But Kelvin is the SI unit of temperature. 0 degree centigrade is equal to 273.15 Kelvin. For convenience, we take 0 degree centigrade is equal to 273 Kelvin after rounding off the decimal. To change the temperature on the Kelvin scale to the Celsius scale, you have to subtract 273 from the given temperature and convert a temperature on the Celsius scale to the Kelvin scale. You have to add 273 to give temperature. Some that change directly from solid state to gaseous state and vice versa without changing into the liquid state. Activity 1.13. Take some camphor, crush it and put it in a china dish. Put an inverted funnel over the china dish. Put a cotton plug on the stem of the funnel as shown in 1.7. Cotton plug, inverted funnel, camphor, solidified. Now heat slowly and observe. What do you infer from the above activity? A change of state directly from solid to gas without changing into liquid state is called sublimation, and the direct change of gas to solid without changing into liquid is called deposition. Effect of change of pressure. When we already learned that the difference in various state of matter is due to the difference in the distance between the constituent particles, what will happen when we start putting pressure and compress a gas? Enclosed in a cylinder, will the particles come closer? Do you think that increasing or decreasing the pressure can change the state of matter? Applying pressure and reducing temperature can liquidify gas. Have you heard of solid carbon dioxide CO2? It is stored under high pressure. Solid CO2 gets converted directly into gaseous state on decreasing of pressure to 1 atmosphere without coming into liquid state. This is the reason that solid carbon dioxide is also known as dry ice. Thus, we can say that pressure and temperature determine the state of a substance, whether it will solid, liquid, or gas. Evaporation. Do you always need to heat or change pressure for changing the state of matter? Can you quote some examples from everyday life where change of state from liquid to vapor takes place without the liquid reaching the boiling point? Water, when left uncovered, slowly changes into vapor. We clothes dry up. What happens to water in the above two examples? We know that particles of matter are always moving and are never at rest at a given temperature in any gas, liquid, or solid. These are the particles with different amounts of kinetic energy. In the case of liquids, a small fraction of particles at the surface having higher kinetic energy is able to break away from the forces of attraction of other particles and gets converted into vapor. This phenomena of change of liquid into vapors at any temperature below its boiling point is called evaporation. Factors affecting the evaporation. Let us understand this with an activity. Take 5 ml of water in the test tube and keep it near a window or under a fan. Take 5 ml of water in an open china dish and keep it near a window or under a fan. Take 5 ml of water in an open china dish and keep it inside a cupboard or on a shelf in your class. Record the room temperature, record the time or day taken for the evaporation process in the above cases. Repeat the above three steps of activity on a rainy day and record your observation. What do you infer about the effect of temperature, surface area, and wind velocity on evaporation? You must have observed that the rate of evaporation increases with an increase of surface area. We know that evaporation is a surface phenomena. If the surface area is increased, the rate of evaporation increases. For example, while putting clothes for drying up, we spread them out. An increase of temperature, with the increase of temperature, more number of particles get enough kinetic energy to go into the vapor state. A decrease in humidity. How humidity is the amount of water vapor present in air. The air around us cannot hold more than a definite amount of water vapor at a given temperature. If the amount of water in the air is already high, the rate of evaporation decreases. An increase in wind speed. It is common observation that clouds drive faster on a windy day with an increase in wind speed. The particles of water vapor move away with the wind, decreasing the amount of water vapor in the surrounding. How does evaporation cause cooling? In an open vessel, liquid keeps on evaporating. The particles of liquid absorb energy from the surrounding to regain the energy lost during evaporation. This absorption of energy from the surrounding makes the surrounding cold. What happens when you pour some acetone nail polish remover on your palm? The particles gain energy from your palm or surroundings and evaporate, causing the palm to feel cool. After a hot, sunny day, people sprinkle water on the roof or open ground because the large latent heat of vaporization of water helps to cool the hot surface. Can you cite some more examples from the daily life where we can feel the effect of cooling due to evaporation? Why should we wear cotton clothes in summer? During summer, we perspire more because of the mechanism of our body which keeps us cool. We know that during evaporation, the particles at the surface of liquid gain energy from the surrounding or body surface and change into vapor. The heat energy equal to the latent heat of vaporization is absorbed from the body, leaving the body cool. Cotton, being a good absorber of the water, helps in absorbing the sweat and exposing it into the atmosphere to easy evaporation. Why do we see water droplets on the outer surface of a glass containing ice cold water? Let us take some ice cold water in the tumbler. Soon we see water droplets on the outer surface of the tumbler. The water vapor present in air on coming in contact with the cold glass of water loses energy and gets converted into liquid state, which we see as water droplets. Now, what you have learned. Number 1. Matter is made up of small particles. The matter around us exists in three states: solid, liquid, and gas. The forces of attraction between the particles are maximum in solid, intermediate in liquid, and minimum in gases. The spaces in between the constituent particles and kinetic energy of the particles are minimum in the case of solids, intermediate in liquids, and maximum in gases. The arrangement of particles is most ordered in the case of solid. In the case of liquid, layers of particles can slip and slide over each other, while for gases, there is no order. Particles just move about randomly. The states of matter are interconvertible. The state of matter can be changed by changing temperature or pressure. Sublimation is the change of solid state directly to gaseous state without going through liquid state. Deposition is the change of gaseous state directly to solid state without going through liquid state. Boiling is a bulk phenomena. Particles from the bulk of a liquid change into vapor state. Evaporation is a surface phenomena. Particles from the surface gain enough energy to overcome the force of attraction present in the liquid and change into vapor state. The rate of evaporation depends upon the surface area exposed to the atmosphere, the temperature, the humidity, and the wind speed. Evaporation causes cooling. Latent heat of vaporization is the heat energy required to change 1 kg of liquid to gas at atmospheric pressure at its boiling point. Latent heat of fusion is the amount of energy required to change 1 kg of solid into liquid at its melting point. Some measurable quantities and their units of measurement: temperature Kelvin, length meter, mass kilogram, weight Newton, volume cubic meter, density kilogram per cubic meter, pressure Pascal. Here, the end of this lecture. Thank you.